Welcome to this series. In the next several videos, we introduce database concepts. During part 1 of the 3-part series, we introduced the topic of database systems. Please take a moment to read the learning objectives for this video. Database is a collection of related data and its metadata, organized in a structured format for optimizing information management. Database stores a collection of end-user data and metadata. It solves many problems involving data management in almost all spheres: business, research, and administration. DBMS is software that enables the easy creation, access, and modification of databases for efficient and effective database management. The DBMS serves as the interface between the user and the database. The database structure itself is stored as a collection of files, so we can access the data in those files through the DBMS. Database system is an integrated system of hardware, software, people, procedures, and data that define and regulate the collection, storage, management, and use of data within the database environment. DBMS manages structure and controls access to data. DBMS is the intermediary between the user and the database. It enables data to be shared and integrates many users' views of the data. Typically, the database system is divided into 5 main elements: hardware, software, people, procedures, and data. Hardware is the system's physical devices. Software includes operating system, DBMS, application programs, and etc. People are all users of the database system. Procedures are the rules for design and usage of the database system. Data is stored information in the database. A typical DBMS has users with different rights and permissions who use it for different purposes. The uses of a database can be broadly categorized. The first one is administrators. They maintain the DBMS and they are responsible for administrating the database. They are responsible to look after its usage and by whom it should be used. They create access profiles for users and apply limitations to maintain isolation and for security. Designers are the group of people who actually work on designing part of the database. They keep a close watch on what data should be kept in what format. They identify and design the whole set of entities, relationships, constraints, and views. End users are those who actually reap the benefits of having a DBMS. End users can range from simple viewers who pay attention to the logs or market rates to sophisticated users, such as the business analysts. Data has enormous potential when managed properly. Data management ensures that the data is in the right place at the right time in the correct format and that usage is governed by all users. Managed data that's high quality, consistent, and compatible can be used to make informed business decisions and report, optimize business operations, reduce costs, and generally improve overall operation management. Unmanaged data may lead to faulty conclusions, create chaotic data environments, and etc. Database defines the database expected use. It helps to avoid redundancy and ensure data integrity. Poorly designed database generates errors and leads to bad decisions. One of the DBMS functionality is creating and managing the complex structures required for data storage, thus relieving you from difficult task of defining and programming the physical data characteristics. A modern DBMS system provides storage not only for data but also for related data entry forms, or screen definitions, report definitions, data validation rules, procedural code, structures to handle the video and picture formats, and so on. Also, DBMS hides the complexity of relational data model from the user. Data integrity management is another important DBMS function. The DBMS promotes and enforces integrity rules, thus minimizing data redundancy and maximizing data consistency. Security management is another important function of DBMS. The DBMS creates a security system that enforces user security and data privacy. DBMS must also provide facilities for recovering from hardware or software failure. The backup and recovery subsystem of the DBMS is responsible for recovery. For example, if the computer system fails in the middle of a complex upgrade program, the recovery subsystem is responsible for making sure that the database is stored to the state it was before the program started executing. Since database systems involve people from all parts of the organization with a variety of information needs, the development and operation of database system must be carefully planned and managed. Database design and application development divided into following 5 phases: planning, analysis, detailed system design, implementation, and maintenance. The first phase is to assess the goal of the organization and study and evaluate alternative solutions. The second phase is to examine problems defining during planning phase in greater detail to get better understanding of the system functional areas, actual and potential problems, and opportunities. It also helps to evaluate database environment, which includes existing hardware, software, raw data, and processing procedures. At the third phase, a designer completes design of system processes, which includes all necessary technical specifications. At the fourth phase, the database is created and the system is customized. The fifth phase is the maintenance. Identifying and documenting business rules are very important to the database design. Business rules allow the creator to develop relationship participation rules and constraints and then create the correct data model. Sample business rules could be one department has many employees or employees have one department. Sources of business rules are managers, policymakers, department managers, written documentation, procedures, and etc. Business rules also allow the designers to understand business processes and the nature and scope of the data. They're a communication tool between the users and designers, and also help to standardize the company's view of the data. Traditionally, data was organized in file formats. A modern DBMS has the following characteristics. It's a real-world entity, meaning that the modern DBMS is more realistic and uses real-world entities to design its architecture. It uses the behaviors and attributes too. For example, a school database may use students as an entity and their age as an attribute. It also has the relation-based tables. It allows entities and relationships among them to form tables. A DBMS is entirely different from its data. It's isolated. A database is an active entity where the data is passive. DBMS also stores metadata, which is the data about data, to ease its own process. DBMS follows the rules of normalization and it helps to reduce the redundancy. Consistency is a state where every relation in a database remains consistent. There exist methods and techniques which can detect attempts of leaving the database in consistent state. DBMS can provide greater consistency as compared to earlier forms of data storing applications. Also, DBMS is equipped with query language, which makes it more efficient to retrieve and manipulate the data. DBMS follows the concept of ACID, which is atomicity, consistency, isolation, and durability. These concepts are applied on transactions which manipulate data in a database. ACID properties help the database stay healthy in multi-transactional environments and in case of failure. DBMS supports multi-user environment and allows them to access and manipulate data in parallel. Though there are restrictions in transactions when users attempt to handle the same data item, but users are always unaware of them. Also, DBMS offers multiple views for different users. A user who is in the sales department will have a different view of the database than the person working in the production department. Security is another feature. It offers methods to impose constraints while entering data into the database and retrieving the same at the later stage. Advantages of the DBMS is improved data sharing, which means that the database helps to create an environment in which the end users have better access to more and better managed data. Improved data security. The more users can access the data, the greater the risk of the security breaches. DBMS provides a framework for better enforcement of data privacy and security policy. Also, it minimizes data inconsistency, improves data access, and improves the decision making. There are still some disadvantages, which are the increased costs, management complexity, maintaining currency, and the frequent upgrade and replacement cycles. To summarize, the database system is an integrated system of hardware, software, people, procedures, and data. It defines and regulates the collection, storage, management, and use of data within the database environment. Business rules are the brief, precise, and unambiguous descriptions of operations in an organization. There are three different types of users, which are the administrators, end users, and designers. There are several advantages of the DBMS, which are improved data sharing, improved data security, minimized data inconsistency, improved data access, and improved decision making. There are still some disadvantages as well, which are the increased costs, management complexity, maintaining currency, frequent upgrade and replacement cycles.